Hey, everybody. Welcome to a Signal 65 Video Insights. I'm your host, Ryan Stroud. I'm the president of Signal 65. I've got Mitch Lewis, who is one of our primary AI testing engineers here at Signal 65. And we're joined by a couple of special guests. We've got Brian, who is the director of product marketing at Phison, and Chris, who's a director of technical marketing at Phison. And we're going to talk about a really interesting product and solution called aiDAPTIV Plus that came out from Phison pretty recently that we did some testing on. Signal 65 has now a Lab Insights report. If you go to our website and check it out, you can read about this product. But we're here to talk about, what the problems are that it's trying to solve, what our results were, kind of some forward-looking ideas about what this kind of technology will be useful for. So I'm super excited to jump in. Thank you both for joining us here today.
Thanks, Ryan.
Great. Happy to be here.
So I want to kind of start by setting the stage of why a solution like this might need to exist before we kind of go explain what it is. I think that's something that we tend to miss a lot are the challenges around deploying and implementing AI today. We tend to think about AI, at least I do, and I know a lot of our audience will think about it as you're either talking about hundreds and hundreds of GPUs in a data center someplace, or you're talking about what AI can I run on my NPU on my laptop, as an example. But as it turns out, there's a huge spectrum of AI, where it gets run, how it gets run, but there's problems that come with every other implementation. So I'm curious, Brian, if you can kind of talk to what some of those problems that Phison saw that they then were able to build a solution for.
Yeah, and a lot of it comes from our own experience at Phison, where we wanted to apply the benefits of AI to doing our product designs, our supply chain analysis, all kinds of things in order to operate the business. But it was all private data, right? So we didn't want to be running this up in the cloud because then we would lose control of that. We don't know what's happening to it from a privacy or data sovereignty standpoint. So our CEO said to the team, hey, can we just run this behind our firewall, do it in-house, go configure it, come back with the price tag, and we'll see what we can do. And they looked at it and they spec'd out the right system, and they came back, the infrastructure said to do this on-premise would be $2 million. And he goes, well, I didn't have that in the budget. Go and figure out a better way to do this. And serendipitously, what we do for a living is we do memory. And it turns out when the team examined what was driving that $2 million price tag and building up the racks and racks of servers, the most expensive component out of all of it turns out to be the memory that's on the GPU cards. And to get a big enough footprint to handle the big models, they had to buy numerous GPU cards filling up multiple servers, filling up multiple racks. But they didn't necessarily need all the GPUs. They just needed the memory on the cards. And so we said, well, we do memory, but we do flash memory, which is very affordable, has very high capacity. And they figured out a way, hey, we can offload those need for memory. Instead of buying lots of GPU cards, you can instead buy the number of GPU cards you need just for the GPUs, for the processors, and then augment it with the memory that we supply. And they figured out a whole memory management scheme, and we're able to implement that for 1/10 the cost. And then it became affordable, and we could apply it. And our CEO goes, we're not the only company with this problem. It's like, this is like anybody who has a privacy concern. Mm-hmm. And in fact, Chris sent me an article earlier this week where they interviewed the founder of OpenAI, ChatGPT, and he was commenting that, well, now in the US at least, the courts have determined that anything that you type in as a query or any documents you upload on ChatGPT will now be held against you in a court of law if they ever want to do that. So if you're a private company and you're thinking about your customer list and your contracts and your product designs, you don't want to have that be shared.
Yeah.
Anybody that's out there. So privacy is the big driver. I think that's table stakes. And then the other one is, can you make it affordable on site? I think those are the two key drivers. just to get in the game. And then there's other things that people would like to optimize with that we can talk about in a minute.
I think one something you said is interesting, right? The idea that GPUs are limiting in some degree. Most people would think of, that the highest end GPUs from NVIDIA or AMD are kind of the pinnacle of AI compute and performance, which they're obviously incredibly powerful pieces of silicon, but they are limited in the sense of memory capacity and what kind of restrictions that places on, how many GPUs you have to run a specific model. This is something Mitch and I see pretty often when looking at any kind of the AI testing we do across cloud or enterprise on-prem infrastructure. Memory capacity makes a big difference. I'm curious, Chris, if you think through, we've had kind of, I don't know, we'll call it like tiered caching systems or what have you across different infrastructures in other different places. You and I have been in the consumer product world for a long time. We've seen a lot of this type of stuff as well. What is kind of like the value proposition that Phison brings to the table in this kind of AI space then?
Yeah, Ryan, it's really all about data management and placement. So we talked a little bit about needing all this memory, and of course this is the most expensive memory in the world right now, HBM, GDDR, right? But we're using it just to hold all this data on these GPUs. The reason why is because to process a model, the data has to be in there or else you get an out of memory error. So to eliminate that, we use the offloading technology, which is actually quite a bit different from the caching technology that we had before with, say, Intel Optane that we wrote about, or SLC drives and just caching the most frequently used. This is actually an expansion model. So instead of just having this HBM memory, now we've got HBM memory plus the massive amount of very high speed, very endurant NAND that Phison has developed. Now, what you do is a 70 billion parameter model is around 1.4 terabytes. So it's very expensive to have 1.5 or 1.4 terabytes of GPU memory.
Yeah.
So we just found a way to augment the location of where the data is held at the time, and that's the hardware side. On the software side, we have a middleware that's the management engine for that data, and so it'll kind of slice and dice the data and send it to the GPUs and retrieve it as needed. And of course, all this is going on over PCI Express, which is a bidirectional bus. We think about the massive speeds of GPU memory, but when it's transferring back off across the PCI Express bus, if it's going to our SSDs or to some other device like a CPU, it's still reduced in speed because you're limited by PCI Express. Our configuration maximizes the bus bandwidth to be able to feed those GPUs at a speed that is appropriate to be able to continue and not see a huge performance like a huge performance penalty.
Interesting. So you talked about a hardware component and a software component. Walk me through kind of what is the aiDAPTIV Plus solution, right? How do you buy it? How do you integrate it with customers or OEMs? Kind of what's its kind of practical business model?
Yeah, I can help talk to that, and Chris, feel free to jump in. But what we're looking to do is deliver this within the systems that people are wanting to use in their day-to-day business. And that can range from, having servers in their own data center. What we're doing is allowing them to buy fewer because they don't need as many GPU cards with their added memory. They just use, high density flash memory with our NAND technology, but all the way down to engineering workstations, desktop PCs, laptop PCs, even IoT devices. So regardless of where you are trying to do your AI processing, it's all going to benefit from the added memory that we provide with our aiDAPTIV Plus technology based on NAND flash. So we've entered into partnerships with vendors across all these different segments and are continuing to build out that portfolio. We're headquartered in Taiwan. We already have relationships with all the major, PC and server vendors there in Taiwan, as well as the different IoT device vendors. We're now been bringing on board U.S.-based vendors or those Taiwanese vendors who have sales operations here in the U.S. So we've entered into partnerships with Main Gear, who we're looking at developing a laptop with them. We should be looking at that later this year. You can buy through newegg.com. You can buy today. You can buy a desktop PC or an engineering workstation with our aiDAPTIV technology. Anybody can go to Newegg and just click an order, and it gets shipped to them the next week. And then we've entered into partnerships with MSI, which is a Taiwanese server vendor. We're going to be looking at sales here in the U.S. And then last month, we announced a product jointly with Store One, which is an enterprise data center storage system vendor. And we've also been displaying on the other end at different trade shows a IoT device from AverMedia based on NVIDIA's Jetson design. So regardless of what your industry is, if you're into some type of remote sensing technology and you need the added memory for better inference performance or capacity to do training of your models there, all the way through doing this at your desktop. This is really has a lot of appeal to developers, university professors, students, AI researchers. And then when you go into production and you're doing this with multiple users, we enable this on servers and storage systems. So it's really the whole gamut of anything that you would do from a compute infrastructure standpoint.
And then, Brian, with that, I want to add. We've talked a lot about the GPUs and the memory and training, but our ProSuite product isn't just about the fine-tuned training with your own data on premise. You can also integrate other features such as RAG that's built into the software, use inference to ask questions about your data, and so forth.
I was going to say, walk me through a sample use case of somebody that is trying to implement AI. They're trying to deploy it. They run into a similar kind of, cost decision. Hey, go invest $2 million or use aiDAPTIV technology. What's an environment or kind of a common use case that a consumer might find themselves in?
Well, I'll give an example. We were just at a trade show, the Gen AI Week conference that was here in Silicon Valley just a couple of weeks ago, and talked to many, many customers there. And one of them, I had a follow-up conversation. They produce software to help the management of childcare centers, right? So you go, okay, that's definitely a niche. And he was very excited about this because he said, look, there is all kinds of unique regulations. Of course, there's a lot of privacy of the different records of the families that take advantage of the services of the different childcare centers. And what his thought was, well, he has the software to help with the day-to-day management. I can take that up a level. I can provide guidance to them. I can incorporate, let's say, all the documents and train them about all the legal concerns about childcare, and they can actually do their queries, the inference queries, on this database that's been finely tuned. And not all of this may be in, a pre-trained foundational model like Llama or DeepSeek. Do they have all the laws about childcare? I don't know, but they certainly then don't have the records of all the clients of this childcare center. And so he said, I'd like to then be able to provide guidance to them. So if they ask some questions in the context of the population of who their clients are, they can give answers and not worry about any of this violating privacy. So his key thing was, how can I provide better services, keep this with full control of the data, but also keep it affordable? So he was intrigued when we were showing at the trade show both a desktop and a laptop machine where he could do this. And the models would be
very interesting.
Enabled to be big enough so they would give accurate answers. So it's really extending the reach of applying AI to small and mid-sized businesses. We have a number of universities who are interested in this so they can teach the students in an affordable way where they get hands-on experience rather than waiting for a slice of time a couple times a week on the server, they can have constant access to this. So we're just basically leveling the playing field, having more people be able to apply AI rather than just the Fortune 100.
Interesting. Now, Mitch, I want to bring you in here because you did some hands-on testing with this solution. Why don't you give the audience a little bit of background? I guess what's the configuration we tested and some of your kind of findings and results that you saw?
Yeah, so we conducted some testing of model fine-tuning on a GPU workstation with 4 GPUs, each which had 48 gigabytes of GPU memory, so not the crazy high-end AI GPUs that are in the really large data centers. And we looked at 4 different models, 2 Llama models and 2 Qwen models, ranging from 7 and 8 billion parameters to 70 and 72 billion parameters. So some smaller ones, and then some really large models that you would definitely expect to run into memory issues on this type of configuration. So we ran fine-tuning both with adaptive enabled and without the adaptive enabled. And what we found was in every single scenario that we ran, they all ran successfully with adaptive. Without adaptive, we end up running into out of memory errors on every single configuration. And the testing that we did was really designed to stress the memory because we wanted to see hey, you can't do this without the software, but with the software you can you can run these models, you can fine tune these really large models, even with fairly modest infrastructure. So the number one thing we found was all of our test cases ran with it, and they failed without it. The other thing that's really was pretty neat that we found was for the really large 70, 72 billion parameter models, we're able to run those on as little as 1 GPU. Now, it did take a while, but it did successfully fine tune. So there's a trade-off kind of it's not going to be the most performant solution, but you absolutely can do this on something that, when we've done other testing projects, we're normally running 8 much larger GPUs with way more GPU memory on there.
Now, I think that's something worth pointing out, and maybe Chris, you can talk to this a little bit too. The adaptive software and kind of hardware integration. The intent is not to say this is necessarily as fast as what you'll get on a high-end cloud or data center GPU cluster, because that's just going to have more GPU resources than somebody who's running this on a laptop, or even what Mitch did his testing on, which was for A6000 NVIDIA GPUs. But the intent is that you didn't have the ability or the option to run these at all in the previous landscape. Is that right?
Yeah, if you were to just use 4 A6000s or 6000 ADAs on their own, you're not gonna fit that 1.4 terabyte of data inside. So it's really just a simple pass fail as far as that goes. With adaptive, we can expand that memory footprint. Without adaptive, you can. As far as the speed goes, it really comes down to compute power, and that's very, very linear. So if you've got X amount of CUDA cores and another system has twice that number of CUDA cores, there is a potential for it to go twice as fast. But at the same time, those CUDA cores are going to cost you a lot, and with each one comes more of that memory. And where the big benefit is for that is maybe you don't need the model in 4 hours. Maybe it's Friday, you start it, you're not going to come back to the system until Monday. We can significantly reduce the cost of training and fine-tuning a model.
Yeah, I've used the analogy several times of, if you don't need an answer, if you don't need your model trained in 10 minutes, but you're okay with an overnight, business model, right? Well, hey, you leave on Friday, you come back Monday, or maybe you want to update it every other day or something like that with new content and information that comes in, that you can go do that and be able to save significantly. And that brings me to my next question for Mitch. I want you to talk to kind of like the cost analysis piece of this and kind of what that looked like.
Yeah. So in addition to running the actual test, we looked at the cost of what is this solution versus an 8 H100 GPU AI server, and there's a little bit of context that goes around this. Of again, these aren't the exact same performance, right? So it's not exactly an apples to apples. But what we did find is the GPU workstation that we were using with the aiDAPTIV solution was 85% less expensive. And so you're not getting that same performance, but it's 85% less expensive, and you're still able to fine tune the same model. So you're getting the same result. It's taking a little bit longer, but as you were saying, if this is something you can do overnight or you don't need it in 10 minutes, I'm sure there's a whole lot of small, medium businesses, all sorts of organizations that would absolutely take that 85% lower cost.
Yeah, and I think there's a lot of other key things to pull out of our time testing and in the report, the user experience, the kind of side-by-side analysis. I'd encourage everybody to go to signal65.com and find this report on the Phison aiDAPTIV software and take a look at it. It's definitely worth a read. Now, I want to kind of close out our discussion and ask a little bit about kind of a forward-looking point of view on things, right? You've kind of already mentioned some of this, Brian, talking about, does this, how does this apply it to laptops? How does this apply to other form factors or spaces? What are some of the other, items on the roadmap, hardware support, different features that may be coming along with this?
Yeah, so we're looking to expand, the audiences that would feel comfortable with this technology. So I think first off, we're continuing to build out the simplicity of it. We have some users like AI researchers, of course, are comfortable with Python and using Linux at a command line. But in the case of the example I mentioned earlier about the CEO of this software company that provides management software for childcare centers, I asked him, so your engineering team is in India, your dev team. Do you want them to be using this, or do you want to use that here? And he goes, I want to use it here. I don't want my engineers touching this at all. The fact that you give me the option of a fully integrated tool set that's on a point and click graphical user interface, no code, he goes, I want to do that. I want my team here, not the engineers in India, to be uploading the data to train the models. He goes, the fact that you make that simple is huge. I love the privacy. I love the affordable cost that fits my budget, and the fact that you make it easy, that's everything I need. So we're going to be expanding to, right now we're Linux, we're expanding that to Windows deployment. Later this year is probably one of our next key items on the roadmap.
Well, Chris, Brian, I really appreciate you joining Mitch and I to talk about this. This is one of those things I remember maybe talking with you guys a year or more ago about this and just thinking, not really understanding what it was and what its applications were and how it would be useful. But having that system here and doing the testing on it actually kind of opened my eyes to ways that we would want to use local training and fine tuning of these models in order to improve our own workflow. So I think this is an expanding area that I think is going to get a lot of attention. So thank you for coming on and talking to our audience and explaining it.
Well, thank you for the time, Ryan. Thanks, Mitch, for your testing.
Thanks for having us. We appreciate it.
And of course, obviously, stop by signal65.com. Go find the research paper, Lab Insights report that Mitch wrote up about this technology. And we'll see you in the next video. Thanks, everyone.